Hi, my name is Dan Donahue, Principal Solutions Architect at Nethopper. In today's video, I'm going to give you a quick overview of our UI. To log into our SaaS, you would go to mynethopper.com and log in with either your existing credentials or using single sign-on. You can create an account using your Gmail, GitHub, or your personal email. I'm going to sign in with my credentials. And from there, you'll see I'm immediately brought to a dashboard. I'll get in a minute. Now, there are three main areas that you'll use in the UI. One is the user area. This is where it has my profile information, any organizations I'm a part of, my subscription info, and so forth. The second part is this up here in the upper left. We see this is where any sort of organizations that you're a part of would be listed here. If you only had a personal account like this one, it would look like this. It would say my name, and it's a personal account. I don't have any resources in there, so I'm going to switch back to Cloudflow. Now, Cloudflow is a fictional company that I use for demo purposes. The third area is on the left-hand side of the UI where you find multiple drawers. We have our dashboard, which is a bird's eye view of all the application networks you have formed, how many clusters are in those networks, the status of those clusters in each network, as well as the objects, number of objects and their status. An object is a Kubernetes application or any sort of infrastructure as code we've deployed. Under the resources category, we have the clusters tab or drawer or page. Here is where I would define the clusters that I'm going to use to add to application networks. In this case, I have three. An Amazon one, a Google instance, and an on-prem one running here in my home. And I can see that they're all part of the same network, which means that they're connected in an application network. And I have other metadata that I put here like location and tags. Tags, you'll see how they're used in a minute. Once I have my clusters defined, I would then create an application network. In this case, again, I have one called DevOps Net. It's got three clusters. It has an on-prem one. It's the hub one, as indicated by the solid cloud there, and two edge clusters, the AWS and the Google. Now, the hub cluster is the one cluster in an application network that has a public IP address from which we create a secure token that the edge clusters can use to securely call home to the hub cluster when they're attached. When they are attached, they form an MTLS connection between the two, thus creating a secure and encrypted tunnel. It's essentially a VPN between all clusters and the hub. And from that, we can then do things like expose the Kubernetes API running on that edge cluster, so things like Argo CD running in the hub can control those. Now, here we have three main statuses. The agent, that is just simply our operator and any other agents we install on the cluster, indicates that it's talking to our back end. The Argo status, because of the way we form this application network in a secure manner, we can have a single instance of Argo CD running in the hub cluster that can control N clusters. In this case, it controls two in addition to itself. We can also have a single instance of Crossplane running in the hub cluster to generate infrastructure as code. So any cluster in a network that Crossplane is created using either Terraform or our public cloud provider's API, it can also manage and mitigate drift because it has a source of truth, which is a GitOps repo. Then I have my hub link status. This is just simply the multi-cloud network connection status for these edge clusters. In this case, this says it's connected to the hub cloud and it's currently up. Then we have a repositories drawer, and on this page, this is where I would add any repository that I plan on using within the platform to do either, again, application deployment, CI/CD pipeline workflows, or infrastructure as code. In this case, I have three. I have a pipeline one. So this one would just simply contain workflows that would have automated CI/CD pipelines. So for example, I have a demo that monitors a source code application repository for any changes. If there are any changes, it then builds an image. It'll create a container, build the image. Then if it's successful, it'll create a Docker image and commit it to Docker Hub. And you can have multiple workflows to do all kinds of work. I have a Cloudflow Dev, which is a source code repository that I use for monitoring and demoing the workflow I just described. And then I have a deployment repo. This contains manifests for applications that I want to deploy. But this would be a single place where you add any repos that you could use anywhere within our SaaS. So you don't need to re-enter repos when you're doing application management, or you re-enter the same repo for infrastructure as code. It's one single place for managing repositories. In our infrastructure as code tab, you would then create a provider. The provider has the information needed for whether it's Terraform or whatever cloud provider you're using for crossplane to generate infrastructure as code. In this case, I created a VCP from existing Terraform, and I have a demo video for that. In the Applications tab, this is where I would give the platform the source repo. In this case, you can see this public repo here. If you go to this URL, you'll see this application in there. And I point to this repo, and I configure this application for a specific path. So it looks at it, and it will look at the, give that application a tag, and we will use that to distribute that application, which I'll show you in a minute. And in this case, if there are any deployments in an application, they're all nested under the application. So for example, if I expand this tab, I could see that this application contains a Kubernetes service and a deployment, and it's distributed to both AWS and Google. Now, why is that? It was distributed there because we had a distribution rule that says any object or application tagged edge should go to any cluster tagged edge. And so we could see here that the guestbook application has a tag edge. And if I go back to my cluster metadata, I see these two clusters at tagged edge, which is why that application got distributed. So from here, I could see what's been distributed. I could see the Argo status in the source repo of where it is. And I can even go into the Argo UI if I want to and take a look at those applications and see them all here. So we give you access to that as well. In the workflows repo, this is where I would point to a repository containing Argo workflows, and in this case I have one that monitors a .NET app, and I have a demo for that. And then in the observability tag, I see local alerts, as well as here I can use Grafana to look at any sort of stats running throughout the application network. I didn't have any current there to look at, but I can also pull up a Grafana tab, and I can look at things from any cluster, because again, with Prometheus running in an application network, Grafana can, over that multi-cloud application network, look at any, harvest data from any of those Prometheus agents running there and then displaying for you. So you have a single pane of glass for your entire application network from an observability standpoint. And that is our UI in a nutshell.